Hello, I don't know if the mic's working, but here I go. Here I'm just gonna show you what was recorded of me doing my work. So here we're at first we're trying to find for the average rate of change, which we use FB minus FA divided by B minus A, which is your new minus your your old divided by same. But for the top, the numerator, it's the output, the new output versus the new output. And for part B, we're looking for the instantaneous rate of change, which is basically a derivative, but using the first principle, which utilizes limits. Here we can see that our our original function, uh, x squared, is gonna get us the derivative, which I did not notate apparently, uh, dx, d over dx, or f prime of x, 2x as your derivative, but we're looking for what is the instantaneous rate of change here. So that will be in highlighted in pink, which is 2. If you need further explanation, I will go over one video over how to do this properly. Uh, First principle for the limit definition of derivatives. So yeah, let me continue. So, and here it gets the formula, I think. So yeah, give me a second. One. So here in the bottom, oh, we'll get there. Here I'm just distributing so I can have it, so I can substitute inside the limit definition of a derivative. Because I don't know if I could put, I'm pretty sure you can do it without doing distribution, but I did it. Here I'm doing A, which is the average rate of change first, which I ended up getting 0.6, which I don't know why I forgot to put the 6 in the bottom. Rate of change, and here, oh yeah, remember instantaneous rate of change means the tangent of a curve. So yeah, here I am substituting everything in. I forgot to end the braces here, which small mistakes happens. And the yellow, I forgot to say this, but the yellow is the common factors. Common, uh, I said the wrong terminology. The light terms, which can cancel out to be equal to 0. And here I am factoring out the h's so I can divide the numerators h with the uh, denominator. So I'll be left with 2x plus h plus 4, which I can substitute 0 now, which I get the derivative. And I am now substitute, so I can get -2. Here I've notated that dx, d over dx, and f prime are the same. They just signify that that's the derivative of function. And here I'm gonna do it again. I've never done this before, so it's gonna be good. And again, we're doing the rate of change here. Uh, it cut this piece, so it's replaying that piece. I'm sorry, but I'm just gonna speed it up. Here, I'm just notating everything by notating by the function, so I don't have to be inputting everything. But here I substituted in did algebra, and afterwards I ended up getting 0/6 again for my rate of change. And here I'm substituting everything inside the limit definition of derivative or Newton's quotient or I think this is first principle. There you go. And here, like I said again, the yellow is the right terms. I'm making them equal to 0, so it can be easier to factor out the h and substitute the 0 for the h, which is the one left here. So I can substitute and I can get my derivative. The apostrophe means prime. I would go over calculus history, but I'm pretty okay with that. And here, I'm not sure if I made a mistake or something, but for C, but yeah. Here, secant, remember secant is just average rate of change. What we've been doing for RAs previously, that's just it. But tangent is the derivative of the function at that spot. So yeah, here I'm substituting everything in again, like I said, into the limit definition of derivative for first principle and unit quotient, and here I'm left with 5 as my function. And here I'm just doing the I forget the name of it, my God, equation of a line, basically, from 1 point. Okay, and here we have more. This is actually my first attempt on this software that I use. That's why it came up big, and later on I just made it thinner and thinner and thinner, the font, and use different colors. Instantaneous rate of change again is tangent, and average rate of change is also secant. So remember that. Those are important key terms that you remember. And there's gonna be faster ways of solving this. You don't have to do everything by the limit definition. But for now, the, we're using the limit definition of derivative or first principle. It's cut off, but yeah, it's d over dx, which is equal to 2. I should put the equal sign to. And here I'm putting the tangent line. This is the equation that we use. Y minus y1 equals slope and parentheses x minus x1 parentheses, close parentheses. The m is the slope. It comes from the word montre, I'm pretty sure, which means to climb up a mountain or to climb. I don't think it was climb a mountain, but it was climb. So that's how we get the m. And here, tangent, we just do our basic algebra from elementary. Your y-intercepts slope form. I'm pretty sure I said it wrong, but yes. And here I have further more work for the next period. Uh, and here IROC just means average rate of change. It's just an acronym. It is utilized, and here I'm just doing arithmetic on the side, so I can figure out what's the slope here, and tangent, like I said, what I meant, preface is IROC. IROC, which is instantaneous rate of change, or the derivative. And I forgot to put the H underneath all of this. But yes, I prefer doing the brackets than parentheses for the parent function, so it can be easily distinguishable. And here I'm just distributing and yeah, distributing. I haven't combined any like terms yet. Now I am combining all the like terms so they can be isolated to zero. And after this, I'm gonna be factoring out the h's so I can divide h over h so it can be equal to 1 here. So we don't have a denominator of a h, which makes this indeterminate or does not exist as a limit. And here we substitute the 0 into the h, which gives us a derivative of 2x minus 5. And here I'm just doing the tangent line, which is y equals 2x minus 5. So, and here I haven't done it, surprisingly, so nice will do. Um, I would get a calculator. I'm getting a calculator now. I can do this all by hand, but it's like 3 a.m. right now, so my brain isn't like full capacity right now. So that's this would be 12 over 6 minus 22, 30, and 18 minus 6, which is equal to negative 3. I put that all mentally. And here we're going to substitute everything inside the limit definition, which is zoom in, so everything doesn't become just a squash of like lines. But do this as fast as we can. And if it doesn't make sense, you can go follow me in my Discord or something. And join the Discord, or which I recommend is send an email. Just send me an email of what question it was, and I will respond to you by like before a day ends. Yes. Okay, I'm gonna distribute x squared plus 2x h squared. This is an identity. I cannot recall the name of it, but it's like the same thing as the difference of squares, just the sum of squares. Yeah, the sum of squares. There you go. I'm pretty sure this is called the sum of squares. If it isn't, someone please check me in the comments below. And 8 minus the parent function, which is 2x. And as you can see, the answer bottom minus x 8 divided by h again. Um, this should have been a limit. I don't know what happened here. H is there. That's what it should have been. After this, we can actually substitute 2x plus 4x, 4x h plus 2h squared minus 7 plus 8. And I'm gonna distribute everything here, which is gonna be negative 2x plus 7x minus 8x. I'm not gonna do the, oh, actually, I was gonna say I'm not gonna do the fraction, but I already did. So yeah, then I combine like terms. So here we go, like terms, another like term, and it doesn't go all the way up there. But here you go. Then we write everything down here. Mm, yes, I hope it's not a long video. This one. I'm sorry if it is. I try not to make it long the videos, but just get very, very like very, um, or like entertained of doing that. It's like my pastime. I really enjoy it, but it's like something that like I don't do anything, so yeah. So I'm like not constantly stressed or anything. I like math, but doing nothing is also good for the mind. And here I can just substitute 0 to h, which will give me my derivative of dx of 4x. I'll rewrite it into x is equal to 4x. And this can be substituted here, y minus, uh, if I substitute this in, it's going to give me 4 equals slope x plus 1. You can do this all into the, the y-intercept form, which I'm doing right now. If I did my math, everything should be fine. It is not equal to the answer given here, so I might have done something wrong. So I probably did something wrong. Let me figure it out. Yeah, the derivative should have been. Oh, I forgot about the 7. That makes sense. Just uh, the 7. I think it'll be fine. Ah, oh no, I did something wrong. 7 should give me -7. I substitute -1. Okay, yeah, -11. Yeah, this is your derivative. I messed up here. Yes. This subsequently would have been wrong, which I could have just deleted and erased it all. Get the bigger eraser. Sorry for my mistake. I was about to make a mistake eventually. So sorry. But here it would have been It's the same thing, right? Yeah, it is. So it would have been 11 equals 4 x, plus 1. And this would have been 4x plus 5. And this would have been equal to 4x plus 15, which does not equal to this. So something went wrong, or it's just me. So yeah, if I did something wrong, please leave a comment. Thank you for watching, and I hope you enjoyed the video.